Fantastic. Well, thank you so much, Mina. And our next speaker is going to be Aaron Gray, who is going to be talking to us about the Severn technology section filter. Can you hear me, Aaron?
I got you loud and clear, ready to run.
All right.
All right, let's just jump to the next slide. So Severn Technology's taken its technology into multiple different fields, and this just kind of highlights what they are. So let's just jump to the next slide. So our technology is fairly straightforward and simple. It consists of stacking a bunch of plates on top of each other. Just think like a stack of CDs on top of each other. The flow comes from the outside, down through a narrow channel, across over through a small opening and out the downside. The advantage of this technology is the small raised pads I can control down to under 100 nanometers, so I can adjust the depth of the filter pretty well to whatever we want, from 10 microns down to 150 nanometers, depending on the need of the system. It's a depth filter because we do the first filtration on the outside edge. You can see that in the top and the middle. Those incoming channels can be from 100 to 300 microns, so they act as the first filter, and then the cross channels act as a second. Next slide, please. So the other thing that we can do is we can modify the designs to catch larger particles on an outer edge, smaller particles till we get to the final ones. We've actually built this particular structure for a different application, but it allows us to create multiple different patterns and trap in another set of depth filters. Next slide. We also have the ability to stack these features on top of each other to create multiple different channels and flows in different dimensions. And allows them to be down into the nanometer scale. We've done 13 nanometers is the smallest filter that we've done in this area, which allows us to filter out all bacteria and viruses. Next slide. The advantage of our technology allows us to do two things. One is filter, which means you trap all the particles. The second is we can actually do a separation technique where we can flow the air in or the water in through the channel, clean it, and through these down flows, we'll actually only have clean air. The rest of the particles stay within the primary channel or exit back out into the regular atmosphere.
Aaron, you have 1 minute remaining.
Thank you. So this allows us to basically take air outside, which is dirty, bring it in, clean it, and leave the dust outside. Next slide. This gives you an idea, just a little bit better of it, how it works and where the spherical components of it. Next slide. The other thing we're able to do is, because these are a variety of different plastics, all of which we can mold with any plastics. We can charge the surface, we can do a deposition on it, we can create a surface tension, we can add a biologic on the surface of it. So we can actually change the characteristics of each of the filters to either act as a biokill or attract and repel. We can create a charge or a anti-charge on it. Next slide. And the other thing is in production, these things are fairly low cost. A stack of CDs are about 20 cents each, and we can use these on a roll to roll. They get down to 5 cents. Next slide. So this is not just science, this is proven technology. The picture of the right is drawing from a wastewater plant, from the wastewater pond itself, cleaning it out to the results on this were—
Aaron, your time has elapsed.
Thank you.
Okay. Yeah. Thank you so much, Aaron. Okay. We're going to